Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Erfan, and today I have gathered a bunch of past year paper questions, the topicalized one, and the topic today that we're going to look at is numbers and accuracy. So we're going to start with a few basic concepts such as prime numbers, rational numbers, irrational numbers, right? And then finding HCF, LCM, doing some estimations, and then we move on to accuracy, finding rounding numbers up to certain level of accuracy. And lastly, we will look at some boundary questions, how to find the upper and lower bound of quantity. Without any further ado, let's start with the first question. So you're given two numbers, 36 and 90, and you're asked to find the highest common factor of these two numbers. So as I told you before in previous videos, there are two ways you can actually solve this question. And I suggest you to stick to whichever method that you're comfortable with. So method one is basically prime factorization, and method two is division. So I'm gonna perform both of these methods very quickly. So in this method, you have to rewrite each number in the product of its prime factors. So 36 can be rewritten as 2 squared times 3 squared, right? And 90 can be written as 2 times 3 squared times 5. And if you're wondering how I got these numbers, I already discussed about this in previous video, but I'm going to do this quickly here. So 36, you see what is the lowest or the smallest prime factor that you can divide 36 by. That is 2 basically. If you divide that by 2, the quotient is 18. You divide that by 2 one more time, and you get 9. Now I move on to the next prime number, which is 3. You divide that by 3, you get 3. You divide that by 3 one more time, you get 1. So 36 is basically 2 times 2 times 3 times 3, which I can write it in this format, the exponential format, right? Same thing for 90. You can do that here quickly. 245 divided by 3. That is 15. Divide by 3, 5. Divide by 5, 1. All right. So now, if you're looking for HCF, you have to look at the common factors, which is basically 2 and 3, right? So you exclude the 5, and you have to target the lowest index. So as you can see, the index of 2 here is 1, the index of 2 here is 2, so I choose the lowest one. The index of 3 in both cases is 2, so it doesn't really matter. And finally, the answer is 18. So 18 is the highest common factor, or the biggest number basically that both of these numbers can be divided into. And for division, you basically write both numbers down and you see what is the biggest basically number that you can divide these two by that number. Well, 9, I think it works well here. It gives me 4 and 10. So I can actually divide these two numbers further by 2. This gives me 2, this gives me 5. And between 2 and 5, well, I can't find a number that I can divide both of these numbers by that, right? 2 is only divisible by 2, so 5 is only divisible by 5. So you stop right there, and the product of these two numbers gives you the HCF. However, if you continue, like if you divide 2 by 2, that gives you 1. So you leave out the other, you just copy it down because 5 is not divisible by 2. And then now you take off the 5, you divide that 5 by 5, it gets you 1. And 1, you just write it itself. So if you continue all the way down to the point that you get 1 and 1, that gives you LCM. So LCM of these two numbers is basically 2 times 9 times 2 times 5, which is basically 180. Using this method, also LCM means write all the factors, list all the factors, common and non-common. So that is 2, 3, and 5. So, and then with the highest index, so this is 2, this is 9. And if you perform this multiplication, you will see that, sorry, this should be 2. So that is 9 times 20, which is 180. So I found the LCM of these two numbers just as a practice. So moving on to the next question. So for next question, I'm just going to use the factorization method, the prime factorization. 20 and 24. 20 is 2 raised to the power of 2 times 5. 24 is 2 raised to the power of 3 and times 3, right? Basically, this is 3 times 8, and 8 can be rewritten as 2 raised to the power of 3, or 2 cubed. And now I have to list all the factors, common and uncommon one, which is 2, 3, and 5. Now I go for the index. I choose the highest one, 3. So here I have only 1 3. So I have only 1 5. The index is 1. And the answer should be basically 8 times. This is 8 times 5, 420. So that's it. That's the answer. The LCM of these two numbers. Question number 3, Louis and Hans both have their birthday on January 1st in 2002. Louis is 13 and Hans is 17 years old. Okay, which is the next year after 2002 when both their ages will be prime numbers? So already at 2002, their ages is prime numbers, right? Louis is 13 years old, Hans is 17 years old. So, okay, if I go with 6, yeah, 6. If I add 6 to both, you get 19, right? And here you get 23, which both of them are prime numbers again, right? 19 is a prime number, 23 is prime numbers, and all I did, I added 6 to both. So that's the next year. So don't go too far. Let me see, did I go too far? How about I add 5? No, if I add 5, this is 17, which is prime. But 5, if I add 5 to 17, that gives me 22. 22 is not prime. It can be divided by 2. So that's it. The answer is, what's the next year after 2002? 2002 plus 6, that's 2008, right? So in which year was Hans twice as old as Louis? Well, this is, okay, this is a past year paper question. The second part, we're gonna learn how to do it when I teach you guys about equations. However, since it's here, maybe you can give it a thought. It's not related to this topic, but it's not a really difficult question to solve. After all, it carries only 1 mark. So in which year was Hans twice as old as Louis? So we have to go backwards, right? So this is 13 and 17. So if we go backwards, I believe if I deduct 9. If I deduct 9, that would be, this gives me basically 8, so minus 9, and minus 9, that gives me 4. So 8 is basically double of 4. And in which year was that? So we have to go 9 years back. Right now it's 2002. So 2000, I'm sorry, 1993, right? 1992, that is 10 years back. 1993, that is 9 years back. So that's it. So moving on to the next question, question number 4. Okay, on January day in Munich, the temperature at noon was 3 degrees Celsius. At midnight, the temperature was -8. So this is a common question that they ask for range or difference. So if you're trying to find the range or difference between two numbers, you have to take the biggest one, which is 3, right? That's very obvious because the sign of 3 here is positive. So, and you minus that by the smallest number. So we have 3 minus -8, right? And that gives us 3 plus 8, which is 11. So this is quite easy question, I understand, but believe me, some students, they still make mistake when it comes to finding the difference or range between two numbers. So just take your time. It is pity if you just lose mark over this question. It carries 1 mark. Usually in paper 1 and 2, you see this type of questions. Question number 5, the table gives the average surface temperature in degrees Celsius on the following planets. Okay, these are the temperatures. Calculate the range of these temperatures. So if you have a bunch of numbers and they ask you to find the range of them, regardless of what those numbers represent, in this case, that's temperature. It could be the height of the students in a class, right? It doesn't matter. What you have to do is to take the biggest one and, take the smallest one and subtract it from the biggest one. So the biggest one, obviously, it's here, 350. And the smallest one among the negatives are this from Pluto. So 350 minus -240, and that should gives us 590, right? So that's the range, okay? The range means biggest minus the smallest. So which planet has a temperature of 20 degrees Celsius lower than that of Uranus? So Uranus is here. It says lower than, so then -20, right? You have to subtract that by 20, and then what do we get? -220. That's Neptune, right? So which planet? That is Neptune. All right. So next question. The sum of the prime numbers less than 8 is equal to 7. So find the sum of the prime numbers less than 20. Okay. So you have to be very careful. The smallest prime number is 2. However, the first sentence is giving us a hint. You don't need to go all the way back to 2, 3, and 5 and start counting from the beginning, because they already did it for you here. So less than 8, we know it's 17. So go ahead and find the prime numbers between 8 and 21. And after that, you add them up and then add it with this 17 here. Because between 1 and 8, we have to include that as well, right? Because when they say less than 21, it means from 1 all the way to 21. So from 1 to 18, it's 17 already. We have that. But from 8 to 21, so let me list the prime numbers quickly here. We have the first one is 11 after 8, then 13, then 17, then 19, and that's it. So add these together, these four numbers. For that, you can actually use your calculator, but these numbers are easy to work with. 11 and 19, that is 30. 13 and 17 is also 30. Together is 60. So between 8 and 21, the summation of prime numbers is 60, and before that it's 17, as stated in the question. We add them up, and in total we get 77. So the sum of prime numbers less than 21, meaning which I list them here for you: 2, 3, 5, 7, and then the next one is 11, 13, 17, 19 should be 77. Next question, the sum of the prime numbers less than x. Okay, this is interesting because we don't know what x is. So let's say x is here. Less than x should be 58. So, and remember, this is the second part of the same question. So in the first part, we should get help from the first part. So all the way from 1 to 21, that gave me 77. So if they want 58, I'm going to subtract the last prime numbers that I added to these numbers, which was 19, right? So if you do that, does that give us basically 58? Well, yes. So it means x should be less than 19, right? So x should be less than 19, because if x is greater than 19, and if you include 19, then from part A, the sum of the prime numbers are going to be 77. So x should be less than 19, which is 18. So basically, if you add these numbers, 2, 3, 5, 7, 11, 13, 17, you should get 58. If you add 19 to it, which they ask us in part A, we get 77. So you should get help from part A. Okay, there is a reason they're giving you these questions in order. So don't panic. This was not a difficult question at all. Maybe later on you can think about it and see if you have any issues with that or not. Question number 7. On a mountain, the temperature decreases by 6.5 degrees Celsius for every kilometer increases in height. So at 2,000 meters or 2 kilometers, the temperature is 10 degrees Celsius. Find the temperature at 6,000 meters. So from 2,000 to 6,000, I have to go up 4,000 meters, right? And I know for each 1,000 that I go up, the temperature drops by 6.5 degrees Celsius, right? That's the value given in the question. So how many thousands I have in 4,000s? 4, right? And for each 1,000, the temperature drops 6.5. So in total, I'm expecting the temperature to drop by the value of 26 degrees Celsius, right? So as simple as that, that's the answer. So you see in chapter 1 and 2, they're just asking you, they just want to make sure you know how to play around with numbers. That's all. And you know the different types of numbers. Okay, without using a calculator, now this is accuracy. We have to round these numbers to one significant figure. So 10.3. So if it's one significant figure, it means keep the highest significant figure, the digit that has the highest value, and just erase the rest. So 10.3, I have to keep 1, right? But you cannot write 1 that is wrong. That's not what I mean. So 0, you have to keep 0. Okay, this 0 has a meaning, so don't just erase everything. So 10.3 is 10 to 1 significant figure, 19.5. So since 9 is greater than 5, I add 1 unit to 1. So basically I get 20. So I'm gonna rewrite everything here. So 10.3 becomes 10, 19.5 becomes 20, 88.9 becomes 90. Why? Well, this digit is 8, which is greater than 5. So you ignore it and you add 1 unit to the digit next to it, to its left. So that becomes 9. And when you ignore this, when you remove this, you have to replace it by 0. So that's 90. 43.2. I'm sorry, this is minus, right? That's subtraction. 43.2. So 3 is less than 5. So you just ignore it and you replace it with 0. And the answer, you can do it without calculator. It's very easy now. This is 200 and this is 50. And the answer is 20 divided by 5, 4. That's the answer, right? So next question. A lake has an area of, okay, this might be a little bit tricky because we're given in square meters, okay, and we are asked that is 63 billions, right, and 800 millions. So, but they ask us to write it in square kilometers and then correct it to 2 significant figures. So 1 meter is actually 1,000 kilometer, right? Or 1 kilometer is 1,000 meters, right? It doesn't matter which way you write it. However, 1 meter square is basically 1,000 square kilometer, right? So this should be squared as well. So it means if you want to convert these square meters to square kilometers, well, basically you have to divide it by 1 million. So I could have used the exponential notations, but since I haven't reached that chapter, the chapter of indices, so I'm not gonna do that. I could have written it as 10 to the power of negative 6. For those students who are familiar with this format, go ahead, suit yourself. However, since I haven't reached that chapter yet, so I'm just trying to use the very fundamental approaches. So you just divide it by 1 million, this number, and the answer is automatically in square kilometers. And dividing by 1 million means erase 6 zeros, right? And the answer is 63,800 kilometers squared. And now I have to round it to 2 significant figures. So I want to keep these 2 digits. And the third digit, when you look at it, its nature is basically its value is greater than 5. So when you erase it, just make sure you add 1 unit to 3, which is to its left. So the answer is 64,000 square kilometers, right? As simple as that. So moving on to the, so basically when you're dealing with area, you have to be very careful, right? This is not 1 dimension, this is 2D. And when we get to 3D, you have to be careful as well. So basically the index becomes 3 in that case. Anyway, we will look at these type of questions in the following chapters. So moving on to the next question. All right, we're given a bunch of numbers and we're asked to write down the prime number, a prime number. So that's the easiest thing because 2 is a very famous number. 2 is the only prime number which is even, right? Which is even. The other prime numbers are all odd. So and that's the smallest prime number which exists. So 2, right? And then moving on to this question, a cube number. So, all right, cube number, what you can do, well, actually, the answer is very clear to me. It should be 216 because I'm quite good with numbers. However, it doesn't matter. You can examine these one by one by using your calculator. There is I don't know which series or which type of calculator you're using. So you can press shift. On my calculator, I have to press shift and then the square button, because above it, you can take the cube root basically. So you have to take cube roots of each of these numbers. And if you get a round number, like an integer, if you get an integer as the answer, then it means that number is basically a cube number. So if I do it for 216, I get, I should get 6, right? So let me, okay, 216, it is 6. However, let's do it for 214, for example, and I get 5.9814, and it keeps going, right? So this is not an integer. So just do this procedure, and for each of these numbers quickly, see whether you get an integer at the end or not. So the cube root of 216 is basically 6. So moving on to the next question. Okay, almost similar to previous questions. So we're given a bunch of numbers. They ask us to list all the integers. So X is a set, and all the elements or members of that set should be integers. So list the members, -1, and square root of 36 is basically 6. So that's an integer as well. So -1 and square root of 36. So don't write the answer for that. So don't write 6, even though it's correct, but you have to choose from these numbers. Okay, so please write down the square root of 36 itself. So the rest, I don't see any integer. Y is irrational. So a misconception here at this point, students, they think since these are integers, the rest should be the answer to second part. And they just go ahead and immediately list down these numbers, which is wrong, because upon further investigation, you realize that 3.5 and -2.5, which is -2.5, these two numbers are rational numbers, right? Because they can be rewritten as a fraction. 3.5 is basically 7/2. -2.5 is -5/2. Any number that can be rewritten as a fraction is called rational number. So these two are not irrational. However, the irrational ones are these two. And even if you key that in your calculator, key it in, and you will see that you get a very weird number. And it's a decimal number with no pattern. So basically the answer is square root of 2 and square root of 30. Okay, having said that, we move on to the next question. Okay, we're given a table and we have to fill it up basically. They did the first row for us, a number, it's a squared and it's cubed, okay. Now, okay, 121. So it's a famous number. However, you can use your calculator, they want you actually, because these numbers, they get quite big. So key in 121 and take the square root of that. You just have to press this number at this button on your calculator, and then key in 121 and then press the equal button, and it should give you 11. And how do you find the cube? Well, you can either multiply this by 11, or since you found the original number itself, just key that in and then raise it to the power of 3, right? And that should give you 1,331. So for the other two, you have to take the cube root, which I already explained to you in previous question. Just use the shift button on the calculator. So 2,744. So this is 14, right? This number is 11. This is 14. I do the same thing for now. This 0, they purposely put it there to confuse you. So since it's before 3, it doesn't have a value. It's not counted. So just key in 343, and that should give you 4. And then after that, you raise both of these numbers to the power of 2, or multiply it by itself. This should give you 49, and this should give you 196. And that's it. That's how you fill up these blanks. And moving on to the next question, question number 13. Now this is upper and lower bound. So let's start with easy question. This is the length of a car, and it's correct to 1 decimal place. Write down the upper and lower bound of the length of the car. So upper, basically upper bound and lower bound, or LB, right? So I better write, okay, the upper bound and lower bound. Now the technique is to have basically the level of accuracy which is specified. In this case, it's 1 decimal place. So this is 1 decimal place, right? Divide that by 2, half it, and then that gives you 0.05. So what should I do with that? You add it to this number, you get the upper bound, and you subtract it from this number, you get the lower bound. So 0.05 plus 4.2 is 4.25. And you subtract it from 4.2, you get 4.15. So the technique, the procedure is always the same. Just have the, basically have the level of accuracy. In this case, it's 1 decimal place. It could be 1 mm, it could be 1 cm, it could be the nearest 10 or nearest 100. It doesn't matter. You always divide that by 2, and then add it to the original number to get the upper bound, and subtract it to get the lower bound. So maybe if we do next questions, that's gonna you grasp it better. So 32,000. Okay, this is the number of people at a football match. So it is corrected to the nearest 1,000. Okay. I believe we are asked to do the same thing. So I have to write, I don't know why the rest of the question is not appearing here, but basically they want us to find the upper and lower bound, right? I'm sorry, they said write this number to the nearest 1,000, sorry. So this is not rounded. I have to round it to the nearest 1,000. And obviously that is 32,000, right? 493, that is less than 500. So when they say nearest 1,000 divided by 2, same procedure, 500. So if it's 500 or more than 500, so you move on to the next 1,000. If it's less than, so you go back to the previous 1,000. So that's 32,000 is basically the nearest one. So at another match, there were 25,500 people to the nearest 100. Okay, so this one is rounded for us to the nearest 100. So in a form of an inequality, meaning which like that, as you know, the lower bound should be included. However, the upper bound should be excluded. So don't write the equality here, just less than, there is no equality. And then what should I put for upper and lower bound? Well, the procedure, do you remember it? This is the nearest 100. So divide that by 2, that gives you 50. And then add 50 to this number, that gives you the upper bound, basically 25,550. And the lowest bound is, yeah, 25,450. Okay, that's the lower bound. So moving on to the next question. So just remember, you have to have it divided by 2, that's all. So the sides, okay, of triangle, all right, these are the sides, each correct to the nearest millimeter. Calculate the lower bound of the perimeter. Okay, so you have to find the upper and lower bound of, so in this case, since they want the lower bound, so just find the lower bound of each of these values. And how do we do that? Nearest millimeter. So this is 1 millimeter, right? Basically 0.1 cm is 1 millimeter. You divide that by 2 and you get, why I wrote it in cm, because these numbers are written in cm. Even though here they mention millimeter, but I wrote 1 millimeter in this format, basically using cm, which is not wrong. You divide that by 2, the level of accuracy should be divided by 2, and that gives you 0.05 cm. And then you add this and subtract it by these numbers, it gives you the upper and lower bound. So I don't need the upper bound, I just need the lower bound. So, and since we're talking about perimeter, the perimeter of a triangle, all you have to do is just add the sides together. So since they want the lower bound, I add all the lower bounds together, meaning which 5.2 minus this number, that is 5.15 plus 6.25 plus 9.35. And that is the perimeter. I believe that should be, this is 20 and this should be, okay, 60, 75, 20.75 cm. So that's the lower bound, right? So that's it. Moving on. So why I add them up? Because in previous video, I have already explained this for addition and basically multiplication. It's very easy. If you want to find the lower bound, you just mix the lower bounds together. If you want to find the upper bound, you mix the upper bounds together, meaning which either you add them or multiply them. For subtraction and division, it's a bit tricky and you have to be careful. So here we have a formula that's how to find the voltage, basically of across a component, electrical component, which carries a current I and has a resistance of R, right? Maybe you have learned this in physics, but it doesn't matter. You can treat this just as an equation. So measured in 1 decimal place. So this is 1 decimal place. Okay. And why I wrote it here? Because I want to find out what to do. Remember that number which you added or subtracted to get the lower or upper bound? That number is obtained here by this degree of accuracy. So this is 1 decimal place. This is 1 decimal place divided by 2. That gives us 0.05. Now, if they want upper bound, I just add this to these original numbers. If they want lower bound, I just subtract it. So they want lower bound of V. So meaning I have to find the lower bound of these two numbers, which is 3.95, and this is 2.65, right? Just subtract this. from both of them. And since this is multiplication, V is obtained by multiplying R and I. So you just multiply them, right? So there is nothing tricky here. It's tricky if it's division or subtraction, remember that. And the answer is basically 10.47. That is corrected to 2 dp. Okay, so that's the lower bound of V, this value right here. Just as a practice, maybe I do the upper bound. So for upper bound, I would be 4.05, R would be 2.75, and if you multiply them, you get 11.14. That's correct to 2 dp. So you see the range. This is the upper bound and this is the lower bound. But they just asked for the lower bound. That's why it only carries 2 marks. So another equation, which I believe this is the equation of speed, distance over time, right? Then what I need to do, they ask for upper bound for S, but this is division. So if they're asking for upper bound, let's say this is the numerator. If you want to find out the upper bound of this fraction, in this case, it's S. So you have to find the upper bound of the numerator and divide it by the lower bound of the denominator. So that's the technique. So D is in the numerator. I'm going to find the upper bound for D. However, this is 2 significant figures, right? So 2 significant figures is basically 7.6. Okay, I have to add 0.05 here to get the upper bound. So that is 7.65, right? And for this guy, the lower bound would be 0.225, right? So, and then just perform the division. I have to divide this by this. Let's see what it gives me. 34. That's a very round number. I wasn't expecting that, but 7.65 divided by 0.225, that gives you 34. And that's the answer. Moving on to question number 17. I believe there is one more to go. So a circle has a radius of 8.5 cm. Correct to the nearest 0.1 cm. So this is, guys, this is the thing that helps us to find the upper and lower bound. You divide this by 2, you get 0.05. So you add it to this number. So the radius is basically between 8.55 and 8.45. So this is the lower bound, this is the upper bound. So now they said the lower bound for the area of the circle is P pi. Okay. And the upper bound for the area of the circle is Q pi. Find the value of P and the value of Q. So, okay. What I need to do, if you remember, the area of a circle is pi r squared. So meaning which r has to be multiplied by itself twice. So if they're asking for the lower bound, so since this is the case of multiplication, I have to divide the lower bound by itself, right? That helps me to find P, because pi is just a constant, right? It doesn't really affect the final answer. So P is basically R times R, but which are the lower bound? So I'm gonna go ahead and multiply 8.45 by itself. And the answer is, so basically P is found to be, let me write it, or raise it to the power of 2. So that's 71.4T, right? And for Q, the upper bound is basically 8.55 raised to power of 2. And that should give me 73.1 actually. Yeah, that's enough. So yeah, that's it. That's the final answer. Very straightforward. Moving on to the last question. The length of a side of a regular hexagon is 6.8 cm. So it's a hexagon. Hexagon, it means it's a polygon with basically 6 sides, right? 6-sided polygon, and it's a regular. So we have all the sides, their value is 6.8 basically. Correct to 1 decimal place. So 1 decimal place, meaning which that's 0.1 divided by 2, you get 0.05. So you add 0.05 to 6.8. So if this is the side, let's say the L represent the sides, the lower bound is 6.75 and the upper bound is 6.85. So what are they asking us? Find the smallest possible perimeter. So perimeter is the summation of all these sides together. And since they're regular, so I'm just gonna calculate one of them and multiply it by 6. So the lower bound, since they ask for smallest possible, the lower bound for 6.8 is 6.75, and you multiply that by 6, it should give you 40.5, right? As easy as that. So that takes care of the last question. I hope you guys have enjoyed the video. If you have any questions, please go ahead and drop your question in the comments below. And don't forget to follow me in the future videos. Having said that, I think it's a good place to stop right here. Thank you guys and have a nice day.